Okay, so we'll look now at modulus functions. So the symbol for modulus are your two straight lines down around whatever you are finding the modulus of. And what they mean is we're ignoring minus signs basically. So modulus of -2 just gives us 2. So the first thing then we'll have to do is solve equations then that have modulus in it. So the modulus of 2x plus 5 equals 9. So the easy way to solve this equation, say 2x plus 5 equals 9, or 2x plus 5 equals -9, and then solve those two. So 2x would equal 4, and x would equal 2, or 2x would equal -14, and x would equal -7. So slightly harder then if we have the modulus on both sides. So the modulus of 2x minus 1 equals the modulus of 4x plus 3. So the easiest way to solve this is to square both sides. So 2x minus 1 all squared equals 4x plus 3 all squared. So when we square this out, we get 4x squared minus 4x plus 1, squared the right hand side, 16x squared plus 24x plus 9. Bring everything across to the one side and we get 12x squared plus 28x plus 8. I'm going to divide by 4 then to make it a wee bit easier, and we get 3x squared plus 7x plus 2. We're going to factorise that quadratic, and we get x plus 2 upon 3x plus 1. So x equals -2 or -1/3. Okay, and our third one then is modulus with an inequality. Do it the same way as we did with the one above, and we just square both sides. So 2x plus 1 squared is greater than or equal to x plus 3 squared. Square that out, we get 4x squared plus 4x plus 1 is greater than or equal to x squared plus 6x minus 9. Bring everything across to one side, and we'll get 3x squared minus 2x minus 8 is greater than or equal to 0. Factorise that, we get 3x plus 4 upon x minus 2 is greater than or equal to 0. So remember, this is a quadratic inequality then, so we need to sketch the graph to get the region correct. So it goes through at -4/3 and 2. We want where the graph is greater than or equal to 0. So that's these regions that I'm shading in. So that means our values are x is less than or equal to -4/3, this region, and x is greater than or equal to 2, this region here. Okay, our next part then is sketching modulus graphs. So we'll start with our first one, and we're going to sketch y equals the modulus of x. So the first thing to do is to draw what the graph would look like without the modulus. So draw the graph y equals x. And you should know it goes straight up here and it goes through 0. Okay? The point on the x-axis, that's the important one, and now we're going to draw the graph of y equal the modulus of x. We're going to reflect this part of the graph above the x-axis. So that part of the graph stays the same, and this part of the graph will be reflected up like that. Okay, our second one, y equals the modulus of 2x minus 3. So draw the graph without the modulus. So y equals 2x minus 3. We know that that's going to go through -3 down here, and it's going to go through 1.5 on the x-axis. So this is our important point here on the x-axis. So whenever we draw the graph of the modulus of 2x minus 3, we mark on our 1.5, and then this part of the graph is reflected up like this, which makes, if this is minus 3 down here, this will be plus 3. Our third one, y equals the modulus of 3x squared minus 2x minus 8. So a quadratic graph. Again, draw the graph without the modulus sign. So it goes through minus 4 over 3 and 2, and it crosses down here at minus 8, and looks something like that. Whenever we put the modulus sign in, again the points on the x-axis stay the same. And the minus 8 will flip up to 8. So this part of the graph and this part of the graph stay the same, and instead of a curve going down, we will have a curve going up like that. Okay, on our fourth one, y equals the modulus of x plus 3. Now note, it's just the x that's a modulus, the plus 3 is separate to that. So again, let's consider the graph y equals x plus 3. It's going to go through 3 here and minus 3 here. And instead of the point on the x-axis being the important one, it's the point on the y-axis is the important one. So to draw the modulus of x plus 3, mark on our point of 3 here. This part of the graph stays the same, and now this time, if we imagine that's our mirror line there, we're going to reflect this part of the graph up with that mirror line and get something like that.